We will now use the concepts of the three laws of motion to solve problems. Now, in solving problems, we will follow some steps. Step 1, isolate the object or point on which the various forces are acting. Now, we will be looking at the forces acting on the object. And the net force is the sum of all the forces acting on the object. What is the net force equal to according to the second law of motion? The net force equal to mass times acceleration. So in order to find the net force, first isolate the object or point on which those various forces are acting, and if necessary, write the forces in the component form. Well, you know how to write a vector in the component form. Now remember, a vector has a magnitude and a direction. The direction is always measured with the x-axis. So if you have a force that makes an angle theta with the x-axis, its x component f sub x will be f cos theta, and its y component f sub y will be f sine theta. You know that, and we will be using this as we go on. So, if the forces are in the proper x and in the proper y direction, you don't need to do anything with it. But if the force is in an arbitrary direction that makes an angle theta with the x-axis, then write the forces in the component form as the x component is f cos theta, the y component is f sine theta. Therefore, f equal to f cos theta I plus f sine theta j. Alright. Third, apply the laws of motion and form equations. Well, F net equal to ma. That is the main law that we will be using to form equations. And finally, solve the equations for the unknown. This is the method we're going to use in solving all types of problems in this section. Alright, let's start with a simple problem. A stalled 1800 kilogram automobile is towed by another car with a horizontal rope, and the cars accelerate at the rate of 0.25 meter per second squared. Find the tension in the rope. So, when a stalled car is being pulled by another car using a cable, the tension in that cable is the net force. The net force to produce the acceleration is actually that tension force, and we are required to find that tension force. Alright, here is the stalled car. I think it is a 1969 Oldsmobile or something. Is that right? Looks like it. And it is being towed by the towing truck. And there's a cable there. You need to find the tension force on that cable. So we are looking for that tension force. The tension T on the cable is a measure of the force applied by the towing truck on the towed car. Now, the mass of the towed car, the old wreck, is m equal to 1800 kilogram. The acceleration produced on that car is 0.25 meter per second squared. So, an acceleration of 0.25 meters squared is produced on a mass of 1800 kilogram, and that can be done only by a net force. What is that net force? That net force is the tension on the cable. So it is a very simple problem. The net force needed to produce this acceleration is F net equal to MA, and that F net is the tension. So that tension therefore equal to MA, T equal to 1800 kilogram times 0.25 meter per second squared, and that will be 450 Newton. Okay, let's do another problem. A bullet of mass 1.8 times 10 to the negative 3 kilogram, moving at 500 meter per second, impacts with a large fixed block of wood and travels 6 centimeter before coming to rest. Assuming that the deceleration of the bullet is constant. Well, I use the word deceleration because it is a negative acceleration. I should have actually used the word acceleration because acceleration can be positive or negative. The bullet is brought to a stop, means the acceleration is negative. And find the force exerted by the wood on the bullet. Well, in order to find the force, we need the acceleration. Is that right? We have done this kind of problem actually before, calculating the acceleration. The bullet hits the block of wood with an initial velocity V0 equal to 500 meter per second. This is the block of wood, and see, you can see the bullet coming. The bullet came with a tremendous speed of 500 meter per second and hit the wood here. It is not stopped there. The moment it hits there, it has this velocity. V0 is 500 meter per second. And now it is going to go in and stop. Its velocity there is 0. The final velocity is 0. So when the bullet is at the front of the block of wood, its velocity is 500 meters per second. When it is brought to a stop, its velocity is 0. And what is the distance moved by the bullet in coming to a stop? Is 0.06 meter. This is that distance, 0.06 meter. Well, you have the initial velocity, final velocity, displacement. Can you calculate the acceleration of the bullet? What equation you will use? Now remember, all the equations of motion that we developed in Unit 1 are going to be used here. Without those equations, we cannot survive. So you must be familiar with it. We have the initial velocity V0, we have the final velocity Vf, we have the displacement x. The equation that describes that motion is Vf squared equal to V0 squared plus 2ax. Is that right? There is no time in there. So first we obtain the acceleration of the bullet from this equation. Vf squared equal to V0 squared plus 2ax. Vf is 0. 0 equal to 500 squared plus 2a times 0.06. Solve for a from there. I'm going to leave it for you to solve it on your own. I got a equal to negative 2.08 times 10 to the 6 meter per second squared. That is a tremendous acceleration. Negative means it is directed opposite to its velocity. So this is the acceleration. Now, we know that an acceleration can be produced only by an unbalanced force. Alright, tell me, what unbalanced force is responsible to produce this acceleration on this bullet? It is the force applied by the block of wood. Is that right? The block of wood will resist the movement of the bullet through it. In other words, the force applied by the wood on the bullet is directed opposite to its motion. So that is the net force. The negative sign indicates that the acceleration is opposite to the velocity. The bullet is moving forward. The force applied by the wood is in the opposite direction. That means the acceleration is opposite to velocity. The acceleration, this acceleration is caused by the net force on the bullet by the block of wood, which means F net equal to ma, and we are looking for that net force applied by the wood, and that will be mass of the bullet is 1.8 times 10 to the negative 3 kilogram. That is here, and multiplied with the acceleration, and we get that force is negative 3,744 Newton. Tell me, why is the force negative? The force is negative because it is opposing the motion of the bullet. The force is directed opposite to the direction of the velocity. Because we started by taking the velocity positive, the force is directed opposite to that. It is negative. Okay, let's do another one. A particle of mass 2.5 times 10 to the negative 6 kilogram moves in the x direction with a constant velocity. If applied forces F1 equal to 5 Newton at an angle 30 degrees to the x-axis in the first quadrant, and F2 equal to 3 Newton at 37 degrees to the x-axis in the third quadrant, act on the particle, what is its acceleration? What other force applied simultaneously will allow it to maintain constant velocity? Now remember, if an object has to maintain constant velocity, the net force on it has to be 0. Alright, what are the forces acting on this particle? Can you draw these forces in the XY coordinate system? What is the first force? F1 is 5 Newton at an angle 30 degrees to the positive x-axis, that is in the first quadrant. Here, F1 is 5 Newton at an angle 30 degrees in the first quadrant. The second force is 3 Newton 37 degrees to the x-axis in the third quadrant. That means it is this angle that is 37. Therefore, what is the angle that this makes with the positive x-axis? Remember, all vectors need to be identified with its angle measured from the positive x-axis. If this vector makes an angle of 37 degrees with the x-axis in the third quadrant, that is this angle, then the angle it makes with the positive x-axis is 37 plus 180, that is 217 degrees. So the two forces on this particle are 5 Newton at an angle 30 degrees and 3 Newton at an angle 217 degrees. We need to find the net force. That means we need to add these two force vectors. What do you do to add them? To add them, first we write the vectors in the component form. That's the only way to add them. So, how do we write this in the component form? 5 Newton at an angle 30 degrees. When you write that in the component form, it will become F1 is 5 cos 30 degrees I plus 5 sine 30 degrees J. The x component and the y component, and obtain their values. Now you got to do this along with me. Keep your calculator ready and obtain these values. 5 cos 30 degrees is 4.33 Newton, and 5 sine 30 degrees is 2.5 Newton. Therefore, F1 is 4.33 Newton I and 4.33 Newton I plus 2.5 Newton J. Now, the angle F2 makes with the positive x-axis is 217 degrees. Therefore, F2 is 3 cos 217 degrees I plus 3 sine 217 degrees J. And use your calculator to obtain these values. That will be negative 2.4 Newton I minus 1.81 Newton J. You have now identified the x and y components of both the forces. Can you add these forces now? Yes. The net force F net is F1 plus F2. So in adding, we add the x components and then the y components. Yeah, you are familiar with it, is that right? So adding the x component, you get 4.33 Newton minus 2.4 Newton I plus adding the y components 2.5 Newton minus 1.81 Newton J, and this is the net force. Simplify these quantities. That will be 1.93 Newton I plus 0.7 Newton J. This is the net force on the particle. This net force is now going to produce an acceleration. Alright, we have F net equal to 1.93 Newton I plus 0.7 Newton J. Now you know that F net equal to ma, therefore A, the acceleration, is F net divided by m. Now notice here, F net has an x component and a y component. If you divide the x component by m, you get the x component of the acceleration. You divide the y component by m, you obtain the y component of the acceleration. So this will be 1.93 divided by 2.5 times 10 to the 6 F over m, the x force divided by the mass, and that will be the x component of the acceleration. The y force divided by the mass. Did I say this is the acceleration? No, this is the mass. The x component divided by the mass gives you the x component of the acceleration. The y force divided by the mass gives the y component of the acceleration. Simplify this, what do you get? That will be 7.7 times 10 to the 5 meter per second squared I plus 2.8 times 10 to the 5 meter per second squared J. This is the acceleration of the object in the component form. Can you write that in the magnitude angle form? Well, how does it look if you want to write it in the magnitude angle form? The magnitude of the acceleration is, how do you obtain the magnitude? This is the x component, this is the y component. The magnitude will be square root of x squared plus y squared. So the magnitude is A equal to square root of, well, square root of x squared plus y squared. So you need to square those quantities. It will be like this, 7.7 times 10 to the 5 squared plus 2.8 times 10 to the 5 squared. Alright, can you calculate that on your calculator? I'm going to leave it for you to calculate. Well, I have got a value here, and that is 8.19 times 10 to the 5 meter per second squared. That is the magnitude of the acceleration. Please check if I got that right. Make sure that you square each quantity before adding and then take the square root. Okay, what is the angle or the direction of this acceleration? If this is the x component and this is the y component, the angle theta will be given by tan inverse of y over x. Is that right? Yes. So theta equal to tan inverse of y over x. And when you divide y by x, you notice that the 10 to the power 5 will cancel. It will simply be tan inverse of 2.8 divided by 7.7. And that is 20 degrees. The acceleration produced by those two forces on a particle of mass 2.5 times 10 to the negative 6 kilogram is 8.19 times 10 to the 5 meter per second squared at an angle 20 degrees with the x-axis. You notice here that we are using everything that we did in Unit 1 for adding vectors. Now here we are dealing with force vectors. Okay. Now, the second part of the question is, what force applied simultaneously on this particle will keep that particle moving with a constant velocity? Now, what is the net force on the particle that we just calculated? We just calculated that the net force is 1.93 Newton I plus 0.7 Newton J. This is the net force producing an acceleration on the object. Now, we need to find what force applied on this particle now will balance. In other words, you have to now balance all the forces, that there will be no net force on the object, that the object will continue moving with a constant velocity. There will be no acceleration. Now, what will be that force? In order to bring this to zero, in other words, you need to bring the net force to zero. Is that right? The only way to keep the object moving with a constant velocity is to keep the net force zero. Now, how would you make this net force zero? Well, it's very simple. If there is a 1.93 Newton I, then apply a negative 1.93 Newton I will nullify the x force. If there is a 0.7 Newton J, then apply a negative 0.7 Newton J. That will balance the y force. So the equal and opposite force will be F equal to negative 1.93 Newton I minus 0.7 Newton J. This force will balance this so that the net force will be zero. Okay, let's solve another problem. A lamp with a mass of m equal to 42.6 kilogram is hanging from wires as shown in this figure. Here is the figure. I hope you can see all the parts of that figure. You have a lamp of mass 42.6 kilogram hanging from, there are 3 cables in there. Alright, find the tensions in the 3 wires. Now, what is the method that we discussed? Isolate the object or point on which the forces are acting. Now, this problem needs to be done in 2 stages. In the first stage, we identify the lamp as the object and identify the forces acting on the lamp. In the second stage, we identify the point O as the point at which several forces are acting. Alright, let's start by first identifying the lamp as the object on which the forces are acting. Tell me, what are the forces acting on the lamp? One force acting on the lamp is its weight acting vertically down, and the lamp is held in position by this cable, and the tension on that cable is T1. Those are the two forces on the lamp. Alright, so I have now the lamp here. I'm going to mark the forces on the lamp. The first force on the lamp is its weight mg, and the other force is the tension T1 that is on this piece of string. Okay, the weight mg and the tension T1 are the two forces acting on the lamp. Since there is no net force on the lamp, is there a net force on the lamp? How do you know? Well, you know, if there is a net force, there will be an acceleration. If there is a net force downward, well, heaven help us, the whole thing will fall down. If there is a net force upward, well, of course we will go to heaven then. Well, since none of this is happening, there is no net force on the lamp. That means you can now write an equation. Is that right? Now remember, when you write equations, they are vectors, so you need to use the proper sign. T1 is a positive vector, mg is a negative vector, so that will be T1 minus mg equal to 0. And that gives you T1 right away. T1 equal to mg. We know m, we know the value of g. That will be 42.6 kilogram times 9.8 meter per second squared, and that is 417.5 Newton. So that simple operation of identifying this lamp as the object on which the net force is 0, we were able to obtain one value. We now know T1. So wherever we want to use T1, we can now use 417.5 Newton. Alright, now you notice that I have changed my diagram. I have now identified O as the point. And did you see that earlier that tension T1 was acting up? That means that was supporting the lamp. When the cable is supporting the lamp, the tension on it is upward. But now when you consider the point O, the direction of the tension is downward. That tension is pulling the point O downward. Did you understand how arbitrarily I can change that direction? Yes, indeed. Now, if you notice in here, let's watch this one. When this mass is hanging, the tension on this cable is upward because it is balancing the weight of the mass. But if you now look at the forces at this point, that tension is now downward because that force is pulling this point downward. So when you now consider the forces at the point O, the tension T1 is actually downward. Alright, we will now consider the forces acting at the point O, and in that case the direction of T1 is downward. There you are. Alright, let's draw those in here. This is the point O, and the tension T1 equal to 417.5 Newton is acting downward. Alright? The tension T1, can you write that in the component form? Well, it is a proper Y force. Can you write that in the component form? This is made up of 0x and negative 417.5 in the Y direction. Therefore, look at the way I write that. T1 equal to negative 417.5 Newton J. That is the proper way to write this force. This is a negative Y force. That is what we have said here. T1 is a negative Y force, and write that in the component form. T2 makes an angle of 120 degrees with the x-axis. How do I know that? Well, this is T2. Let me see if I can show that to you. Well, this is the x-axis. We are told that this angle is 60 degrees. Well, that disappeared, the one I drew. There you go. Now, this is 60 degrees, this is the x-axis. That means this angle is 60 degrees. Is that right? Yes. And the angle made by T2 with the x-axis is this angle. That will be 180 minus 60. That is 120 degrees. So the angle made by the vector T2 with the x-axis is 120 degrees. It's very important to recognize the direction of each vector. Tell me, what is the angle made by T3 with the x-axis? Because this angle is given to be 30 degrees, this angle also will be 30 degrees. Okay. Now this is T2 that makes an angle of 120 degrees. Can you write T2 in the component form? Therefore, T2 will be T2 cos 120 degrees I plus T2 sine 120 degrees J. The x component of T2 plus the y component of T2. And that will be using the values of cos 120 and sine 120. You know cos 120 is negative. So that will be negative 0.5 T2I plus 0.87 T2J. That is T2. Now, the x component is negative 5. This is the x component. Look at that. It is negative. And this is the y component. So this is T2 cos 120 degrees is the x component. And T2 sine 60 degrees is the y component, which has this value. Negative 0.5 T2, that is this vector, plus 0.87 T2, that is this vector. Alright, we finished with T2. Can you do the same thing with T1? Alright, T1 make, not T1, T3. T1 we already dealt with. T3 makes an angle 30 degrees with the x-axis. It means its component form is T3 equal to T3 cos 30 degrees I plus T3 sine 30 degrees J. And can you obtain these values like this? This is T3 cos 30 degrees. And this is T3 sine 30 degrees. And that will be 0.87 T3I plus 0.5 T3J. Well, we have now three forces acting at the point O. The first force is T1, which is negative 417.5 Newton J. The second force is T2, which is equal to negative 0.5 T2I plus 0.87 T2J. We don't know what T2 is, we need to find T2. And the third force is T3 equal to 0.87 T3I plus 0.5 T3J. What is the situation? Since the net force at that point O is 0, if you add T1 plus T2 plus T3, that net force must be equal to 0. Since the net force at O equal to 0, we say T1 plus T2 plus T3 equal to 0. What does that mean? It means if you add the x components, it must be equal to 0. And if you add the y component, it also must be equal to 0. That is the meaning. When vectors are written in the component form, and if we say adding the vectors will give you 0, it means adding the x components will produce 0, adding the y components also will produce 0. So what do? The sum of the x components must be 0 and the sum of the y components must be 0. That means if you add the x components, look at this, negative 0.5 T2 added to 0.87 T3 must be equal to 0. And 0.87 T2 added to 0.5 T3 added to negative 417.1. They are all y component. There are 3 y components and 2 x components. Look at this. There are 3 y components. This is 1 y component. There are 2 over here. Adding those 3 forces must give you 0. So let's make those equations. These are the equations we had earlier. So adding the x components give you negative 0.5 T2 plus 0.87 T3 equal to 0. Adding the y components give negative 417.5 plus 0.87 T2 plus 0.5 T3 equal to 0. And you have 2 equations. Now let's rewrite these equations. Negative 0.5 T2 plus 0.87 T3 equal to 0. And 0.87 T2 plus 0.5 T3 equal to 417.5. Well, can you solve these equations on a calculator? Well, let me see if I can show that to you. I'm going to keep the calculator in front of the camera and see how best you can see that. Now, these are the 2 equations we have. Negative 0.5 T2 plus 0.87 T3 equal to 0. 0.87 T2 plus 0.5 T3 equal to 417.5. Now write this on a piece of paper so that when I show you that equations are in front of you, because I'm going to take this off. Now the first thing to do is obtain a matrix in your calculator for the coefficients on the left side. What are the coefficients here? The variables are T2 and T3. The coefficients are negative 0.5, 0.87, 0.87, positive 0.5. This is a 2 by 2 matrix. So we are going to make a 2 by 2 matrix on the calculator. Well, let's see if the... Alright. Now this is the TI-83 calculator. What you need to do is the matrix function is on x to the negative 1. You see that? So go second x to the negative 1. That gives you the matrix function. we need to start on here, edit. So go 2 places to the right, there. And we're going to edit a matrix called A. It has been selected, so enter. Alright, enter. And now we need a 2 by 2 matrix. So what you need to do is type in 2. Now where is 2? Alright, here. Type in 2, enter, 2, enter, and then 2, enter, and the cursor now comes in waiting for the numbers. What are the numbers? The first number is negative. Remember, the negative sign is down here. Negative 0.5. That is the first number. Enter. The next number is 0.87. 0.87. There you are. And enter. Now the second row is 0.87. Enter, and 0.5. So you have now in the calculator a matrix with the coefficients on the left side. Alright, let's now go and make another matrix. How do you go make the matrix? Second x inverse. Now this time you are going to edit a matrix B. So go down once. And that is the matrix we are going to use, and enter. This time the right hand side, what are the numbers on the right hand side? It is 0 and 417.5. That is a 2 by 1 matrix, 2 rows and 1 column. So write 2, enter, 1. That's right. So you got a 2 by 1 matrix. And what are the elements of that? 0. So enter, 0, enter, 417.5, enter. There you are. You got matrix A and matrix B. And what all you need to do is quit this. Second, quit, and then go and pick matrix A. How do we pick matrix A? Second matrix. This is the matrix menu, and the matrix A is selected there. So enter. Now take the inverse of that. Now which is the inverse? Look at this key. That is the inverse. So if you have a matrix there, and if you press that, it will say A inverse. Now multiply that with the matrix B. So go and pick matrix B, second matrix. Pick matrix B, come down to 2 and enter. So we have A inverse B, enter. And you notice here, this is the value of the first variable, that is your T2, and this is the value of T3. So the calculator solves the equation for you. Alright, so anytime we have equations like this, you can have equations with 3 variables. And then your left side matrix will be a 3 by 3 matrix. The right side will be a 3 by 1 matrix. So I will not show you this again. I want you to use this method for solving all these kind of equations. Alright? The calculator solved these 2 equations for you. T2 is 360.7 Newton and T3 equal to 207.3 Newton. Now, this is a beautiful problem, and you must spend some time solving these kinds of problems. Let's do another one. An object experiences an acceleration of 3 meters per second squared when a certain force F0 acts on it. when its acceleration, now what is its acceleration when the force is doubled? Well, if you know the second law, you can say that directly, because the force that produces the acceleration is directly proportional to the acceleration. Is that right? Well, so when the force, what is the acceleration when the force is doubled? The force is directly proportional to the acceleration means if the force is doubled, the acceleration will also double. If the force is halved, the acceleration will also be halved. That's the meaning there. So it's a very simple problem. B, a second object experiences an acceleration of 9 meters per second squared under the influence of the same force F0. What is the ratio of the masses of the two objects? Well, that's a very good one. And C, if two objects are now tied together, what will be the acceleration if the same force F0 is used on the combination? Alright, let's start with the data. The applied force is given to be F0. The acceleration that it causes on a mass is A equal to 3 meters per second squared. Mass of the object we don't know, we call it m. Well, therefore we can now write one equation right away. F0 equal to ma. F0 equal to 3m. Is that right? The net force equal to mass times acceleration. Here, the force acting is F0, mass is m, acceleration is 3 meters per second squared. That gives us F0 equal to 3m. That means wherever we use F0, it can now be replaced by 3m. That's very useful information. Okay. When F equal to 2 F0, let the acceleration be equal to A. Then 2 F0 will be equal to ma. Now, but F0 is 3m. Look at the advantage of that. Wherever we have F0, we can now replace it with 3m. The force is now doubled. 2 F0 acting on the same mass will produce what acceleration? We replace our F0 by 3m. What does that give you? 2 times 3m equal to ma. Now watch this. M and m will cancel from either side. It will give you the acceleration right away. Acceleration is 6 meters per second squared. Well, that can be even obtained by arguing that if the force is proportional to acceleration, when the force is doubled, the acceleration also is doubled. So the acceleration therefore is 6 meters per second squared. You see how important that you understand these concepts to do the problems. So I spend a lot of time in teaching you these concepts. Try and learn this. B. A second object experiences an acceleration of 9 meters per second squared under the influence of the same force F0. Now tell me, is this second mass greater than or smaller than the first mass? The force F0 acting on the first mass produced an acceleration 3 meters per second squared. The same force acting on a different mass produces what kind of acceleration? 3 times the acceleration. So tell me, is this m prime smaller or bigger than m? If the same force has to produce a bigger acceleration, then that mass has to be smaller. How much smaller? If the acceleration has to be how many times? The acceleration has to become 3 times. Therefore, the mass is 1/3 of the original mass. Now look at the way I'm arguing out. This problem can be done simply by thinking. That means m prime is actually 1/3 of m. Only then will it have an acceleration 9 meters per second squared when the same force is applied on it. Alright, let's go into the proper way. The acceleration is 9 meters per second squared. The same force F0 acting on m prime produces an acceleration of 9 meters per second squared. That means F0 equal to ma, the same equation. F0 equal to ma. M here is m prime, acceleration is 9 meters per second squared. Well, you know that F0 can be replaced by 3m. So, F0 is replaced by 3m. 3m equal to 9m prime, and therefore m divided by m prime is 9/3. You understand that, isn't it? You see, 9m prime equal to 3m, or m prime equal to 1/3 of m. In actual fact, you don't need all these steps to figure it out, that m prime is 1/3 m. You can figure it out quickly by saying that if F0 produces an acceleration of 3 meters per second squared on a mass m, the same force producing an acceleration of 9 meters per second squared on a mass m prime, this m prime, since the acceleration is 3 times the original value, the mass has to be 1/3 of the original mass. So m prime equal to 1/3 m. Okay, what is it that we need to find now? See, the two objects are now tied together. What is the total mass? M plus m prime. Well, this m prime can now be replaced by 1/3 m. So that will be m plus 1/3 m. What is m plus 1/3 m? That is 4/3 m. So the total mass now is 4/3 m. And we are applying the same force F0 on this 4/3 m. We want to find the acceleration. The net force equal to ma. The net force is F0. And the total mass is 4/3 m, and acceleration we need to calculate. Tell me, how will we do this problem? What is the next step? Well, glaringly obvious. Replace your F0 by 3m. Is that right? Okay, so F0 is replaced by 3m. 3m equal to 4/3 ma. Look at that. On the left and on the right, m will cancel. And we can then solve for a. A equal to 2.25 meter per second squared. A very good question to understand the concept we discussed. Alright? I want you to look through this again and try to argue this out on your own. Okay, let's do another problem. A force F equal to 6 Newton I minus 3 Newton J acts on an object of mass 1.5 kilogram. Find the acceleration of the object. What is its magnitude and direction? Well, we have done this kind of problem before. Acceleration is F net over the mass. F equal to ma, Therefore, A equal to F over m. This is the force and this is the mass. Therefore, acceleration is, you notice that the force has an x component and a y component. The x component of the force will produce an x acceleration. The y component of the force will produce a y acceleration. So, the acceleration in the x direction will be the x force divided by the mass. That is 6 Newton divided by 1.5 kilogram I. This will be the acceleration in the x direction. Minus, why minus? Because the y force is negative. 3 Newton divided by 1.5 kilogram J, and this is the y component of the acceleration. And that will be A equal to 4 meter per second squared I minus 2 meter per second squared J. This is the component form of the acceleration. How do you write it in the magnitude angle form? Well, the magnitude of the acceleration will be square root of x squared plus y squared. So A equal to square root of 4 squared plus 2 squared, that is 4.47 meter per second squared. And what is the direction of that acceleration? Notice that y is negative, x is positive. Tell me, what is the quadrant in which this acceleration vector is going to be? Y is negative, x is positive. It is the fourth quadrant. So, the direction is theta equal to tan inverse of y over x. Tan inverse of, I'm missing something here, negative 2 divided by 4. Tan inverse of negative 2 divided by 4, and that must be negative 26 degrees. Alright? Now, correct those small mistakes there. Theta equal to tan inverse negative 2 divided by 4, and that is negative 26.6 degrees. I hope you have now a fair understanding of how to do problems using the equations of motion we developed in Unit 1 and the laws of motion. Let's do another one. A 4 kilogram object is subjected to two forces, F1 equal to 2 Newton I minus 3 Newton J, and F2 equal to 4 Newton I minus 11 Newton J. The object is at rest at the origin at t equal to 0. What is the object's acceleration? What is its velocity at time t equal to 3 seconds? Where is the object at t equal to 3 seconds? You notice that these are extensions from the problems we did in Unit 1. Okay, how do we start here? We know there are two forces on a particle of mass 4 kilogram. We need to find the net force and use the net force to find the acceleration. Alright, let's get going. F net equal to F1 plus F2. So, F1 plus F2, add the x components and add the y component. That will be F1 plus F2, the x components will be 2 Newton I plus 4 Newton I. That will be 6 Newton I minus 3 Newton J minus 11 Newton J is minus 14 Newton J. So that is the net force. Add the x components, add the y components. Therefore, what is the acceleration? Acceleration is the net force divided by the mass. We can do that now quickly. You know how to do that. That is x component of the force divided by the mass gives you the x component of the acceleration, and the y component of the force divided by the mass gives you the y component of the acceleration. That will be 1.5 meter per second squared in the x direction minus 3.5 meter per second squared in the y direction. That means if you now use this acceleration to calculate the velocity at t equal to 3 seconds, you need to calculate the x component of the velocity and the y component of the velocity. The x component of the velocity is produced by the x component of the acceleration, and the y component of the velocity is produced by the y component of the acceleration. Alright, let's do that. V0 equal to 0, and we're going to use Vf equal to V0 plus At. Now, V of 3 is V0 is 0 plus A times 3. Now, V of 3 has an x component and a y component. What does V of 3 stands for? Velocity at the end of 3 seconds is acceleration multiplied by 3. Now, when you use acceleration, the x value, that will be the x velocity. If you use the acceleration, the y value, that will be the y velocity. And we can write it together. In other words, if this is the acceleration in the component form, multiply that by 3, you will get the velocity in the component form. Let's do that. So, velocity at the end of 3 seconds is acceleration multiplied by 3. In other words, multiply the x component of the acceleration by 3 minus multiply the y component of the acceleration by 3. That will be 4.5 meter per second I minus 10.5 meter per second j, and this is the velocity vector at that time. And if you want to find this in the magnitude angle form, you can do so. You know how to do that. Alright. In the C part, where is the object at t equal to 3 seconds? What is its position? Because the object has an x velocity and a y velocity, it will travel an x distance and a y distance. So where is the object? What is the position? There is an x position and a y position. And look at this equation. X of t equal to x0 plus v0t plus 1/2 at squared, where x0 is 0. We will assume that the object is at the origin. So x0 is 0. What is v0? The initial velocity is 0. Yes. So these two terms will simply cancel. And therefore x of 3, the position at t equal to 3 will be, x of 3 will be 1/2 a times 3 squared. And that is, remember, this x really does not represent x. You got to really call it some r, because this position has an x component and a y component. This is the x position of the object at t equal to 3. 1/2 a t squared, where this a is the x component of the acceleration, minus 1/2 a t squared, that is the y component. So this is the x component of the acceleration, and this is the this is the x component of the position, because this is the x component of the acceleration. This is the y component of the position, because this is the y acceleration. That will be 6.75 meter I minus 15.75 meter j. In other words, the particle at that time is 6.75 meter along the x direction in the positive way, and negative 15.75. So the particle has moved. If I use here, the particle has been moving like this. It is now somewhere here where its x position is 6.75 and its y position is 15.75. That is the meaning there. This is where the object at the end of that 3 seconds. Okay, I think we have done enough problems. Do you agree with me? I'm sure you must be an expert in solving problems like this now. Okay, that is the end of lesson 1, and I want you to learn the concept. Now, this lesson was actually full of concepts. I want you to learn them well and learn how to solve problems using those concepts. Well, I'll see you for lesson 2 later on.